In this video, I'm going to go through your pre-calculus Unit 2 review. The entire test is no calculator, so keep that in mind. So these first examples are looking at limits graphically. So we're looking at a piecewise graph. We can look at limits, the one-sided limits. So the limit as x goes to negative 2 minus, the limit as x goes to negative 2 plus, and then the limit as x goes to negative 2. So we're looking at this location, and it should first strike you that we've got different things happening on opposite sides of the graph. So when we come from the negative side, those values are going to 0. From the positive side, we're going to negative 3. Since those are not the same, the limit does not exist. The function value exists, however. F of negative 2 is going to be that 3. But we don't necessarily need to do the left and right hand limits. So here the limit as x goes to 2, both of those are going to the same place, going to negative 1. Okay, looking at g at negative 2. As we go from the negative side, even though there's this little dot, I don't really care what's happening at negative 2, just as we get really, really, really close. So the left-hand limit is 1, the right-hand limit is 1, which means the limit is 1, because it is approaching the same thing from both sides. G of negative 2, however, is 3. So even though it has that little jump, it still has the limit. The limit as x goes to 1, okay, we're going to negative 2 here, negative 4 here, so this limit does not exist. It is not going to the same place. Okay, and then in this last column, we're combining. So the limit as x goes to 0 of f of x plus g of x. We look at 0 on f is negative 2. 0 on g is negative 1. So negative 2 plus negative 1 is negative 3. Product is just the product. So at 2, we're at negative 1. 2, we're at negative 2. So negative 2 times negative 1 is positive 2. 3 times g, so we go to negative 4. 1, 2, 3, negative 4 is going to negative 1. So 3 times negative 1 is negative 3. These last two are compositions. So I'm going to rewrite this one as f of the limit as x goes to 3 of g of x. Okay. For g, we're going to go to 3, which is 0. So this is now just the function value at 0, which is negative 2. G of the limit as x goes to 2 of f of x. So we'll go to 2. The limit at 2 is negative 1. So now this is g of negative 1. So go to the graph of g at negative 1 is at 0. Okay, a new graph here. We're going to look at the limit as x goes to negative 1. Okay, as x goes to negative 1, okay, it's just going to be at this peak, which we'll just go ahead and call 3. As x goes to 1, we can clearly see there's an asymptote here. As we go to positive 1 from the negative side, those are decreasing without bound, so we say that goes to negative infinity. From the positive side is increasing without bound, so we say that is infinity. Okay, as we go to infinity, okay, it's leveling off here at a negative 2. From going to negative infinity is also approaching negative 2. Now we're going to look at some limits numerically. So we're looking at the limit as x goes to negative 2. First thing I want you to do is cross this part off, because we don't care what's happening at 2, or negative 2. So as x goes to negative 2 from the negative side, f of x, these values are approaching 3. From the positive side, they're approaching 3. So we say that the limit exists and is 3. As we approach 2 on g of x, these are going to negative 3. These look like they're approaching 5. Since they are not the same, does not exist. Now be really careful. A common mistake on the test is to look at the x's and not the y values. So we're interested in, as x goes to -2, what's happening down here. Okay, in this next section here, we're evaluating a whole bunch of different limits analytically. We don't have the graph in front of us. We don't have a table of numbers. So the things you're going to pay attention to are, what are we taking the limit? Where are we taking the limit? Is it at infinity or is it at a specific point? And then the structure of the different equations. So these first 3, we're all going to infinity, 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 and it is a rational function. So in that case, you're looking at the degree of the top and the bottom. This first one, the degrees are the same on the top and the bottom. So they're going to grow at the same rate. So the leading coefficients take over. So it's just 5/3. We only care about the highest power. Here, the highest power is in the numerator, which means that top is going to grow faster than the denominator, which means it's going to go to infinity, or you can also label that as does not exist. Both of those are acceptable. The last one, the degree is bigger on the bottom than the top. So as the x goes to infinity, this denominator gets really, really big, but the numerator stays small. So that's going to 0. These next 2 are going to infinity, or in this case, -infinity, but they are not rational functions. So we're still interested in the thing with the highest power, because that's what's going to dictate what's going on. So we want to look at this, which has an odd degree polynomial with a negative leading coefficient. So the graph is going to look something like that. So as we go to -infinity, those values are going to infinity. This one is an even positive, so it'll look like something like that. So as x goes to infinity, it is going to infinity. Okay, in the second column here, we're going to specific values, not infinity. Your first check is plug in the value. If you can plug in the value, then we're good to go. So here I can plug in 2. That'll be 16 plus 4 is 20 minus 1 is 19. Here, we've done a lot of rational ones where we don't get a value, but here we will. Because we're going to have 3 minus 3 over 3 plus 4, which is 0 over 7, which is just 0. Okay, where we get an issue is if when I plug in the value, we get a 0 in the denominator. So here, if I plug in that, we get 0 on the top and 0 on the bottom. This does not mean that the limit is undefined. It means we need to do some work. So we are going to factor. Okay, this case, the minus 3's cancel. So then this is just equal to the limit as x goes to 3 of x plus 3, which no longer has any issues. So I can just plug in 3 and get an answer of 6. Okay, we still have the same issue here. If I plug in 3 into the denominator, we get 0 on the top and 0 on the bottom. So we will factor again. Still the difference of 2 perfect squares. So we're going to have x minus 3, x plus 3. So that minus 3's do drop out again. So we're left with the limit as x goes to 3 of 1 over x plus 3. Be careful not to, it's in the denominator, so there's still a 1 up here. So this is going to be 1 over 3 plus 3, which is 1/6. Okay, the last one here, if we plug in -4, you will get 0 over 0. So we will factor one more time. Okay, so the numerator To get this 3x, we're going to have a 3x and an x. Okay, and then you just want to play around with different numbers. That would get you -4. So if I have, to get this middle one, if I have 3 times a +4 and an x times a -1, I can get that 11. To get this denominator, we're going to have numbers that multiply to get -20 and add to get 1 are going to be x minus 5 and x plus 4. Okay, so again, we have a common factor. Okay, and then we can plug in our -4 now. So 3 times -4 minus 1 over -4 minus 5. So we get a -12 minus 1, which is a -13 over a -9, which means we have +13 over 9. Okay, this next question says, the mathematical definition of continuity states that a function is continuous at x equals c if it satisfies 3 conditions. What are those conditions? Number 1, there must be a function value. So f of c exists. 2, the limit as x approaches our value of f of x needs to exist. And the third, 1 and 2 need to be the same. So f of c needs to equal the limit as x approaches c. In this next set of questions, we're looking for 3 things. We're going to state whether the function is continuous or discontinuous. If it's discontinuous, the type of discontinuity, and then if discontinuous, why from the definition that we just talked about. Okay, so pretty clearly, this one is discontinuous. Okay, it is an infinite discontinuity. Okay, and it fails the very first thing. F of c does not exist. There is no function value at this. There's also not a limit value, so that would be acceptable as well. Okay, our second one here is discontinuous. Okay, it is either jump or point. I would accept either. Really, it's not going to be point because it has a value here, but I would accept both. The reason, it does have a function value, it does have a limit value, but they are not the same thing. So f of c does not equal the limit as x approaches c of f of x. This one is discontinuous. This would be a jump discontinuity. Okay, it has a function value, but it does not have a limit. So the limit does not exist because it's going to 2 different places at that location. And the last one here, as funny looking as it is a continuous function. Next, we're going to determine continuity from an equation. So we're going to use the definition of a continuity to determine if these are continuous or not at our specific value. So at 2, we have the potential of being discontinuous at the boundary. So first, f of 2 is just going to be 2 squared plus 1, so that's 5. So it passes the first part of the definition. Next, we want to look at the limit. So we're going to have to look at the limit, the right-hand limit and the left-hand limit. So the limit from the negative side, okay, is going to be the limit as x goes to 2 of this first one, okay, which is still going to be 5. If I plug in 2, we get 5. The limit as we approach 2 from the positive side, we're now going to be looking at the other function here, x plus 3. If I plug 2 into that, 2 plus 3 is 5. So this one is continuous because f of 2 equals the limit as x approaches 2. Okay, this one, f of negative 2 is certainly going to exist. So negative 4 plus 1 is negative 3. And I'm just going to look at, as each of these, sorry, this is x minus 3. Okay, that's going to be negative 2 minus 3 is negative 5. So that's going to be bad news for us, or good news, I guess. Okay, that's still going to be negative 3. So it has a function value, but the right-hand limit and the left-hand limits are not the same. So this is discontinuous because the limit as x approaches negative 2 does not exist. Okay, our next one here, f of 5. If I plug that in, we're going to have 5 squared minus 3 times 5 minus 10 over 5 minus 5. So we get 25 minus 15 and 10 is 0 over 0. Okay, so this is undefined at 5, so this is discontinuous because f of 5 does not exist. The limit will exist, and we could find that, but it's unnecessary. We have a point of discontinuity there. It is discontinuous. So now we're going to make continuous functions. So the issue here is going to be the boundary. This is going to be continuous, this is going to be continuous, but what we're interested in is at 2, we need them to go to the same place. So I'm going to look at what's happening to the one that we can't change. Okay, so the limit as x goes to 2 of x squared plus 2 is going to be 2 squared plus 2, which is 6. So that one is going to 6, so we need this one to also go to 6. Okay, so we're going to plug the 2 in for the x, so k times 2 minus 4 equals 6. So 2k equals 10, so k is going to equal 5. So that's our k value. Then we want to graph. So this is now 5x minus 4. And we can graph our piecewise. This is going to be when x is less than 2. This is going to be when x is greater than 2. So our boundary's there. We know what a parabola moved up 2 units looks like. Here. And 4 to 6, which we know. So this will be here. And then it's going to stop at that point, and then we're going to graph 5x minus 4. So 5x minus 4 would go down here, up 5 over 1, up 5 over 1. Part of the reason you're graphing here is to confirm that you picked the right thing. If you got the wrong answer, your line wouldn't start here. It started at a different location. Okay, this one, first thing we need to check is to make sure that these two things are going to the same place when we are going to 2. So I'm going to look at the limit of each of them as we go to 2. I'm going to look at the limit as x goes to 2 of 2x minus 1. And I'm going to look at the limit as x goes to 2 of x plus 1. Well, this one's going to be 2 times 2 minus 1, which is 4 minus 1 is 3. This one, 2 plus 1 is 3. So they are going to the same place. That means my k needs to be 3 in order for it all to sort itself out. Okay, for our graph, when x is greater than 2, we have 2x minus 1. So we'll start here, up 2 over 1, up 2 over 1. Continue with my slope of 2. X plus 1 when x is less than 2. So x plus 1, slope of 1, it meets there. There's the other half of that graph. if the graph of ax plus b over x minus c has a horizontal asymptote at y equals 8 and a vertical asymptote at x equals 4, find a and c. Okay, horizontal is going to be the limit as this goes to infinity. Well, these have the same degree, x over x, so our horizontal asymptote is at 8, which means our a needs to be 8, so the ratio of the leading coefficients is 8. Okay, if it has a vertical asymptote at 4, that means when I plug in 4, we want a 0. Okay, so if we plug in 4 into x minus 4, so my c is -4. Okay, in this next section, we are going to be finding the points of discontinuity and then the equations for vertical asymptotes, horizontal asymptotes, and slant asymptotes. Okay, so the first thing we want to do is look for the point of discontinuity. So we're going to factor. So we factor, this is 3 times x minus 2 on the top, difference of 2 squares on the bottom. Okay, so there is a point of discontinuity because there is a common factor. The x value will be the thing that makes that 0. Then we're going to remove the discontinuity. Okay, we're going to take 2 and plug it into what's left. So 3 times 2 plus 2 is 3/4. That will be our y value. To get full credit, you need an x and a y. Vertical is anything remaining that makes our denominator 0. So that's going to be x equals -2. Horizontal is the limit as we go to infinity. So the limit as x goes to infinity of 3 over x plus 2. Degree is bigger on the bottom. So this is going to go to 0. So we have a horizontal at y equals 0. Slant only occurs if the degree is 1 higher in the top than the bottom. Okay, our next one. Again, we need to factor. That's our first step. So when we factor this top, we're going to have a 2x and an x. Okay, the numbers that multiply to get 15, it's either going to be 1 and 15 or 3 and 5. If I multiply 2 times a positive 3 and 1 times a -5, we get 6x minus 5x, which gets me a positive x there. Okay, but you guys factor how you need. Multiply to get -4, add to get positive 3. Okay, x plus 4 and x minus 1. So there is no point of discontinuity. There's no common factor. Okay, there are 2 vertical asymptotes, anything that makes the denominator 0. So at x equals -4 and at x equals 1. Horizontal, the limit as this goes to infinity, we have the same degree, so it's going to be the ratio of the leading coefficients. So that's going to be y equals 2, and again there's no slant asymptote. Okay, this one factors on the bottom. So 2 things that multiply to get -12 and add to get 4 are going to be x minus 2, x plus 6. Okay, and if you're struggling with factoring, we can always check it by foiling. If I foil this, we get x squared plus 6x minus 2x gets us that, minus 12. Okay, so there is no point of discontinuity here because there is no common factor in the top and the bottom. There is, again, 2 vertical, anything that makes these denominators 0. So that's going to be for this one, x equals 2, and for this one, x equals -6. The limit as this goes to infinity, the degree is bigger on the bottom, so it's going to go to 0. So we have a horizontal at 0, which means we do not have a slant again. All right, our next one here does not have a point of discontinuity. There is no common factor. The vertical asymptote is going to be at x equals 1. Okay, for horizontal, the limit as we go to infinity, the degree is bigger in the top, so it's going to go to infinity, so there is no horizontal. But this is the case where we have a slant, which means the degree is exactly one higher in the top than the bottom. So we're going to do long division here. Okay, so what multiplied by x gets 2x squared will be 2x. Multiply that down, 2x squared minus 2x. We'll subtract that. That's always 0. 5 minus negative 2 is a positive 7x. So we'd multiply this by a 7. And as soon as you have mx plus b, we are done. So my slant here is 2x plus 7. Okay, and one more. We will factor. Okay, here I can pull out an x, which is going to leave me with an x squared minus 5x plus 6. So that's going to be x minus 2, x minus 3. So we do have a point of discontinuity. The x value is going to be what makes that common factor 0, so 2. Then we're going to remove the discontinuity. We're then left with x plus 2 on the top and x times x minus 3 in the bottom. Okay, we're going to plug 2 into that. So 2 plus 2 over 2 times 2 minus 3. So that's going to be 4 over negative 1 times 2 is negative 2, which is negative 2. So the y value of our point is negative 2. Vertical is anything left that makes the denominator 0. So x equals 0 and x equals 3. Horizontal, the limit as this goes to infinity. The degree is bigger on the bottom, so it goes to 0. So there is no slant. So we did a lot of graphing rational functions, but we're kind of boiling it down to a couple simple graphs. So if you can graph these ones, then you are good for the test. So I still want to kind of do my analysis that we were just doing. I want to figure out, are there points of discontinuity? Are there vertical? Are there horizontal? Okay, I already see that there's not going to be a slant. Here I can pull out an x on the bottom. Okay, so I do have a point of discontinuity when x is 0, which leaves me with 1 over x plus 4. If I plug in 0, we're at 1/4. So at 0, 1/4, we have a hole there. We have a vertical asymptote when x equals negative 4. And we have a vertical at x equals negative 4. Horizontal, degrees bigger on the bottom. So we have a horizontal at y equals 0. So vertical, horizontal. And in fact, this is just our parent function, 1 over x, moved to the left 4, which is why we have a vertical asymptote there. So for this graph, I'm going to go from these 1 and 1 to 1/2, 1/2, 2, and then approach this, and then just don't forget about our point of discontinuity. We removed it, but it still is a part of this graph. Okay. The next one, if we factor, we're going to have x minus 3, x plus 2. Okay. So we have a point of discontinuity when x is negative 2. Then we remove it, and we just are left with x minus 3, which is no longer a rational function. It's no longer a fraction. This is just a line. If I plug negative 2 into it, we're going to get negative 5. So we have a point of discontinuity at negative 2, negative 5. The remaining part of the graph is just the line x minus 3. So I go down to 3, slope of 1, back there. Like that. The last thing we covered was tangent lines. So the equations for the tangent lines of absolute value of x, that graph we know looks like that. The tangent line to a line is itself. So at x equals 4, it's just the equation of this line here, which is just going to be y equals x. At -3, that's just going to be y equals -x. And at a corner, if there's an abrupt change, there is no tangent. Average rate of change is just another way of saying slope. Okay, so it's going to be f of 0 minus f of -2 over 0 minus -2. Okay, if you evaluate f of 0, that's going to be -1. F of -2 is going to be 2 times -2 squared plus -2 minus 1. So we get 4 times 2 is 8 minus 2 and minus 1 is 5. So this is going to be -1 minus 5 over 0 minus -2 is 2. So this is -6 over 2, which is -3. Same thing for this one. This is going to be f of 4 minus f of 1 over 4 minus 1. F of 4 is 2 times 4 squared plus 4 minus 1. So it's 16. 32 plus 4 is 36, minus 1 is 35. F of 1 is going to be 2 times 1 squared plus 1 minus 1. So that's just 2. So 35 minus 2 over 3. So 33 over 3, which is just going to be 11. So our next set of questions, we're going to be using this formula. So you will be given the formula. We're going to use that to find the slope of the tangent line, write the equation for the tangent line, and then graph the tangent line. Okay, so we're going to have the limit. Our c is going to be 2. So this c, and this c are 2. So x goes to 2 of f of x minus f of 2 over x minus 2. Okay, f of x is just our equation. X squared plus x minus 12. F of 2, when I plug in 2, is 2 squared plus 2 minus 12. So 4 plus 2 is 6, minus 12 is a -6. Minus -6 all over x minus 2. So we're going to have x squared plus x, -12 minus -6, so we're adding 6 to -12. Sorry, negative, that's -6. So I can factor this. Okay, the nice thing about this kind of factoring is we know x minus 2 better be one of our factors. So the other one here is going to be x plus 3. Remove our common guy. And then plug in 2. So this will be 2 plus 3, which is 5. Okay, now we have that, we can write the equation of the tangent line. So our point is 2, -6, 5 as our slope. So our tangent line is going to be y plus 6 equals 5x minus 2. And you can put that in slope intercept or leave it just like that. To draw the tangent line, we're going to go to our point at 2, -6 on the graph, and we're going to have a slope of 5. So we go up 5 over 1, and then draw our tangent line. All right, so this one's going to be the limit as x goes to -1 of f of x minus f of -1 over x minus -1. Okay, minus, we'll need to find what f of -1 is. So we're going to have 4 minus 5 will be -1, minus 2 is -3. So put that in parentheses there. This is going to be 4x squared plus 5x. -2 minus -3 is a plus 1. So this is going to be x plus 1 times 4x plus 1. So we'll do the limit as x goes to -1 of just 4x plus 1. So 4 times -1 is -4, plus 1 is -3. So my tangent line, my point is -1, -3. My slope is -3. So we're going to have y plus 3 equals -3, x minus -1 or plus 1. Again, you can leave it just like that. When x is -1, so watch the scale on this graph. So there's -1, there's -3. So we have a slope of -3. So there's our tangent line. Okay, the last thing we're going to do is we're going to use this formula, and again, you will be given the formula just like it's written here, to find the slope of any tangent line. So the limit as h goes to 0, f of x plus h is just this with x plus h here instead of x and x plus h here instead of x. So we're going to have 2 times x plus h squared minus 4 times x plus h plus 3 minus f of x. So that's going to be 2x squared minus 4x plus 3. All over h. Zoom in a little bit so you can see a little better. So I'm going to FOIL this. That'll be 2 times x squared plus 2xh plus h squared. Distribute through the minus 4x, so minus 4x minus 4h plus 3, and distribute that minus. Minus 2x squared plus 4x minus 3. And there are stuff that can reduce, but I'm going to wait till my next step to do that. So I'm going to distribute the 2. And then copy all the rest of this straight down. Okay, now we'll cross some stuff off. So the 2x squared cancel, the minus 4x, and the 3's cancel. So we're left with 4xh plus 2h squared minus 4h all over h. Everything contains an h. So we can now divide by h. And we're left with 4x plus 2h minus 4. As h goes to 0, that's going to be 4x plus 2 times 0 minus 4, which is just 4x minus 4. So this is the slope at any point. So if we want to know where the slope is 8, I just set 8 equal to that equation. So 12 equals 4x, so x equals 3. F of 3 is going to be 2 times 3 squared minus 4 times 3 plus 3. So 9 times 2 is 18 minus 12 plus 3. 6 plus 3 is 9. So my coordinates are 3, 9. All right, we're going to do one more of these. F of x plus h, we're going to plug x in here and here. So x plus h squared minus 2x plus h minus 1 minus x squared minus 2x minus 1. Okay, so don't forget to keep writing that word limit. So we'll FOIL that, x squared plus 2xh plus h squared minus 2x minus 2h minus 1 minus x squared plus 2x plus 1. Okay, and then do our canceling. X squared, 2x, and the 1s, everything without an h in it. Okay, so we reduce, we're going to have 2x plus h minus 2 when we divide all those by h. So when h goes to 0, that goes to 0, everything else stays, so we get 2x minus 2. So for the last question, it says find where the slope is 0, which on a parabola, right, that would be the location of the vertex there. So we're going to set 0 equal to 2x minus 2. 2 equals 2x, so x equals 1. F of 1. So 1 minus 2 minus 1 is going to be a negative 2. So the vertex of this parabola would be 1, negative 2. That is your Unit 2 review.